this module, we've been talking about IP version 4 addressing. And to really understand and work with IP version 4 addressing, we need to understand the binary math behind the scenes, how to work with the ones and zeros. That's how we started out this module. Then we took a look at the format of an IP version 4 address. We saw some of the different traffic patterns we might have in our network using IP version 4 addressing. We had unicast, broadcast, and multicast. We saw different ways of assigning an IP address to an end station. Maybe we manually assign that address. Maybe we dynamically learn an address from a DHCP server, or a device might self-assign itself an address. That was called a PIPA addressing, if you recall. Then we got a bit more advanced with the discussion of subnetting. Subnetting involved taking our classful mask and extending that classful mask. In other words, we added ones to the default subnet mask for an IP address. And by doing that, we could take one network and carve it up into multiple subnets. And we went into the math of how many hosts can be supported on a created subnet, how many subnets can you carve out of this classful network using a particular subnet mask. And we went through several practice exercises to really hone our skills in doing that. And we wrapped up our discussion by talking about really the opposite of subnetting. A lot of people call it supernetting. Supernetting, or the term we used, was CIDR, C-I-D-R, classless interdomain routing. Instead of extending the natural mask by adding bits, CIDR, or supernetting, is going to remove bits from the natural mask. That might be useful by a service provider as a common example. Let's say that a service provider is trying to advertise multiple contiguous networks. Instead of advertising those individually one at a time, what if they did this? What if they sent a single advertisement, and that single advertisement was able to encompass all of those individual networks? Maybe we've got a bunch of Class C networks, and instead of using a 24-bit subnet mask, we notice that all of these networks have the first 22 bits in common. We could advertise those with a 22-bit subnet mask with just one network advertisement. That could cut down on the size of our routing table that we needed to support, as an example. That was IP version 4. But these days, we're starting to hear a lot about IP version 6. That's the topic of our next module.